Hi everyone, in today's lesson we want to find the value of square root of minus 1 to the power of square root of minus 1. This is an interesting question which many wouldn't even know where to start. So to get the solution of this, we have solution. So what we need to do first is we know that I is equal to square root of minus 1. So starting from here, we understand that for a complex number, a general complex number can be represented by z, x plus iy. So this is the general form of writing a complex number. Now, if we consider this, we have that I here can be written as 0 plus 1 multiplied by I. So this over here can give us y back. So, and we know that writing a complex number in an exponential form has to do with applying the Euler's formula. The Euler's formula as well also relate to the trigonometry. From the Euler's formula, which is given by e to the power of I theta is equal to cos theta plus I sin theta. Now, this can now be compared with this over here. So if we compare this to this, we discover that cos theta will be given as 0. Y sin theta will be equal to 1. Whereas these two values occur when theta is equal to pi over 2. So it means that if we go back to our I can now be replaced with e to the power of I pi over 2, because earlier we were given that to be e to the power of I theta. So since both results of the cos theta and sin theta occur when theta is equal to pi over 2, so we now replace that, then we have this step. So from this step we multiply the power of both sides by I, then that can be written as I to the power of I is equal to e to the power of I pi over 2, then power I. So we have multiplied both sides with an exponent I over here. So now here we can now recall from our identity of indices, which implies if we have a base of an exponent, say a into bracket to another given exponent, then this exponent can now be merged together by multiplication, and we can write that as a multiplied by b. So if we adopt this identity, then we can apply that to this part. So we now have I to power I is equal to e, we bring this I inside. We have to the power of I multiplied by I, then multiply by pi over 2. So, but what we know is that if we multiply I with I, we will get I squared. And this I squared is given by minus 1. So if we replace this into this, then we have this to be written as e to the power of I multiplied by I multiplied by pi over 2 is written as e to the power of I squared multiplied by pi over 2 is given as e to the power of minus 1 multiplied by pi over 2. And this can properly be written as e to the power of minus pi over 2, which is simply equal to our I to the power of I. So this is going to be our value of the expression we have earlier, and we know this part is what we have as square root of minus 1 to the power of square root of minus 1, so which equates this. So this is the value for our expression earlier. This will be the final answer. So, but this is a more general way of writing the answer, whereas in another form it can also be expressed as equal to e. This expression can also be given as e minus pi over 2 then plus 2n pi. So we can write it in this form as well, whereas this is more common. Okay, this is more common in writing our value for the expression given earlier, which is square root of minus 1 to the power of square root of minus 1. Let's approach this problem with another method. So we have in this method 2, we are going to use our popular known Euler's formula, which is the Euler's equation. So from the Euler's equation, so from this method 2, we are going to be making use of the Euler's equation, which imply e to the power of I pi plus 1 is given by 0. Okay, from here we have that e to the power of I pi is equal to minus 1. That is, if we move this minus 1 to the right hand side. So here we can take the square root of both sides. If we do that, we can write this as e to the power of I pi into bracket exponential half into bracket exponential half equal to minus 1 into bracket exponential half. So this indicates a square root. So now we can put this as e to the power of I pi over 2 if we multiply this half with the exponent equal to, and this can also be written as in a radical form, square root of minus 1. And we know that square root of minus 1 is equal to I, and it is given by e to the power of pi, e to the power of I pi over 2. Now we can raise both sides with the power of I. So we have power I, then power I to both sides. So we can now move this inside. Then we have e to the power of I multiplied by power I, then multiplied by pi over 2 equal to I to the power of I. So, and this will give us e to the power of I squared multiplied by pi over 2 is equal to I to the power of I. And here, then we can write that as I to the power of I equal to e to the power of I squared multiplied by pi over 2. So now this can now be written as, since we know that I squared is equal to minus 1, then we can replace that. Then we have that to be equal to e to the power of minus 1 multiplied by pi over 2. And properly, that is given as e to the power of minus pi over 2. And we know that the value of this is equivalent to 0.20787,957. Here comes the end of the lesson. Hope you enjoyed this. Here comes the end of the lesson. Hope you enjoyed this solution. If you do, please subscribe to this channel, like the video, share the video to your loved ones, and we'll meet in another interesting lesson. Bye. Stay safe.